Hi everyone. Today we're going to talk about section 11.6, counting principles, permutations, and combinations. And actually, lucky for us, lucky for me actually, we're covering the same section in geometry, except it's section 12.3, permutations and combinations. Okay, so when I went through these two sections, they turned out to be exactly the same. So I'm just going to make one video for both classes. Okay, so we're going to start with something called the fundamental counting principle that says the number of ways in which a series of successive things, successive means one after the next, can occur is found by multiplying the number of ways in which each thing can occur. Okay, so our first example is a pizza. So a pizza can be ordered with 3 choices of sizes, small, medium, or large, 4 choices of crust, and 6 choices of toppings. How many different one-topping pizzas can be ordered? Okay, so because we have 3 different sizes, we're going to multiply it by the 4 different types of crust times 6 different toppings. And so that's going to give us, when we multiply, 72 different one-topping pizzas. Okay, so we're multiplying the number of ways in which each thing can occur. In this case, we've got size, crust, and toppings. Okay. How many ways can a 10-question multiple choice test be answered if each question has 4 choices? Well, we've got 10 different questions. So instead of a situation like this that had only 3 things happening, where it was the size, the crust, and the toppings, here I've got 10 different things being multiplied. I like to put a little space here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So think of this as like number 1, number 2, etc. I'll just fill them all in. Okay, so we have 10 different questions here. And we need to figure out, okay, well, how many ways can each problem occur? Well, if I have 4 different answer choices, there are 4 different options here. Likewise, for the next one, when I go to number 2, I still have 4 choices. Let's say it's A, B, C, and D. And actually, the same is going to hold true for all of these. Now, I can sit and multiply this out, or I can write it a little bit easier and say it's 4 times itself 10 times. That's 4 to the 10th power. So when I type this into the calculator, I get 1,048,576. Okay, those are all the different ways that we could answer the questions on the test. Okay. All right. Go ahead and pause the video for a minute and try example 3 on your own. Okay, I won't pause it myself. I'll just give you guys a minute to hit pause and then we'll go through it. Okay, so telephone numbers in the US begin with 3-digit area codes followed by 7-digit local phone numbers. Area codes and local phone numbers cannot begin with a 0 or a 1. How many different telephone numbers are possible? Okay, so I'm going to set up kind of like how we did here. So we've got our phone number. we've got a 3-digit area code. Okay, and then we've got a 7-digit local number. Okay, looks like we have enough. All right, so now we want to think about how many options there are. Now they said that the area code and the telephone number can't begin with a 0 or a 1. So if we think about all of the possibilities, okay, so these are all of our digits between 0 and 9, right? And then we jump to 10 and we start getting into 2 digits. So how many different options do we have here? Well, I can't use these first two. So that only leaves me with 1, 2, 3, 4, 5, 6, 7, 8 different numbers that I'm able to choose over here. Okay, now for the second digit, I can use whatever I want. Any of these numbers are fine. We don't have any restrictions. So there are 10 different digits. Okay, likewise over here, 10 different digits. Now, for the local part of the phone number, which is the 7-digit, it said that we cannot start with a 0 or a 1. So again, there are 8 different possibilities. And then the rest of them, there are no restrictions. Okay, so sometimes writing it out, all of the individual pieces, is helpful. So we're just going to multiply all of these. Okay, so I've got, and you can just type it out if you want, 8 times 10 times 10, oops. Okay, times 8 times, now I need 6 10s, you'll notice I can do 10 to the 6th if I don't want to type them all. Notice there's 1, 2, 3, 4, 5, 6. Okay, all right, so let's make sure we get the right number of zeros here. I've got 64, 3, 6, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Putting our commas in. So we actually have 6.4 billion different telephone numbers. Okay, so a lot of phone numbers there. Okay. Now, a permutation is a special type of counting principle, and it is an ordered arrangement of items that occurs when the order of the arrangement makes a difference. That is the most important piece for permutations. Oh, that's blurring out a little bit. So the important thing, and I'm going to write it in big bold letters, is that order matters. And we'll see a couple examples of why order might matter in a minute. So the notation that we use is N, capital P, little r, okay? So it means the number of permutations of N things taken at R at a time. So we have N things that we're choosing from, okay? R is the number that we're taking at a single time, okay? So right here, N things taken R at a time, okay? So we've actually seen something like this before, something similar to it. So the way that we do this using factorials, so in Algebra 3, we've talked a little bit about factorials where, let's say I've got off to the side here, 4 factorial, it's an exclamation point. What that means is you multiply 4 times 3 times 2 times 1. It's taking that number and multiplying by every integer below it, up until 1, okay? So the setup for a permutation is we do n factorial up top, n minus r, so you subtract these, and do that factorial on the bottom, okay? So for example, if we were doing this one by hand, we've got 13 factorial on top over 13 minus 9 factorial, so we subtract those, okay, and we get 4. So notice that it's n minus r, 13 minus 9 is 4. Okay, so when I simplify this, if I wanted to do it by hand, I would do 13, 12, all the way down to 1. Okay, divided by 4, 3, 2, 1. And then we're going to cancel 4 on top and on bottom, 3 on top and bottom. 2s and 1s cancel. Okay, so that leaves me with, let's multiply these numbers out. So we're going up to 5, and we have 2, oh, actually I'll just write this down here. So we've got 2, 5, 9, 4, 5, 9, 200. So that's telling us that there are this many different options, and we call those options permutations. Okay. Now, obviously, there is a faster way to go about this. If you guys have an 84 or an 83 calculator, I will show you guys the faster way. So those of you in Algebra 3, we've already done this. So I'm going to move this over. There we go. So I'm going to start by putting in the number 13 in, because that's the first number in my permutation. Then the P, we actually need to hit the math button. Okay, I'm going to go all the way over to probability, which is this last one. And you'll notice we have NPR. Okay, and so now we got the N, now we just need the P, which is 9. And notice we get the exact same answer. Okay, so this is a lot faster. I'm totally okay with you guys using the calculator for this. Okay? All right, so let's talk about what it means for order to matter. Okay, so you and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 CEOs, a CEO, an operating manager, and a treasurer. In how many ways can these offices be filled? So the reason why order matters, let's say, so there's 20 of us total, right? So 20 total friends. Okay, and we're choosing 3 officers. Choosing 3 officers. Okay, so the order does matter, because if I pick, let's say, myself, Sally, and Amanda, if I put myself as the CEO, Sally as the operating manager, and Amanda as the treasurer, that's a different possibility than Amanda as the CEO, me as the operating manager, and Sally as the treasurer. Okay, so that's why order matters here. Because the same 3 people could serve as different roles. Actually, ROLES. Could serve as different roles, which would be a different outcome. Right? If I'm CEO in one outcome and I'm treasurer in another outcome, that's a totally different setup, totally different outcome. Okay? So the way that we would type this in is N is the total number of options we have, so 20. Permutation, and we're choosing 3 people at a time. Okay? So out of those 20, actually, I can just, let's go back, oops. Hit the math button. Oh, gotta hit 20 first, actually. Make sure you type in 20. NPR. choosing 3 people, and there are 6840 different possibilities. Okay, so we'll say options / permutations is the word that we use. Okay. All right, so let's go ahead and look at the next one. You need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference? So that's the important part. The order of the books matters. Okay, so go ahead and take a minute and plug this into your calculator. All right, so in this situation, we have 7 books that we're choosing from. The order matters. And we're using all of the books. Notice they didn't say anything about only choosing a certain number of books. So that's why we're gonna have 7 over here, okay? So what does that give us when we type it into our calculator? 7, permutation 7, I got 50, 40 permutations, or ways to arrange. Okay, now if we wanted to do this by hand using our fundamental counting principle, that is possible here if we just think about this as a whole, like what's actually happening. So for the first book, just one sec. All right, so for the first book, I've got a space right here. Here's the second, here's the third, and so forth. All right, let's see if we can find another way besides the permutation formula. So there are 7 different options for the first book, right? Now, if I take a book and I put it on the bookshelf, I only have 6 different options to put in the second space. Well, all right, now I've put 2 books up on the shelf. I only have 5 options for that third space because there are 5 books left to choose from. There are 4 books left to choose from for the fourth space. Only 3 left over here, only 2 left, and only 1. Okay, so let's see if we end up with the same answer by using our counting principle. If I type this stuff into my calculator, so we have, let's see here. Notice you get the exact same answer, okay? Now, obviously, I think this is a little bit easier as long as you know that you're using a permutation because the order does matter here, okay? All right, let's jump to the second page. Our other type of process is called a combination. So a combination, order makes no difference in the arrangement, okay? So I'm gonna write order doesn't matter. Okay, so I want you guys to take a minute and read through these few scenarios and just try to decide, is it a permutation or a combination? Does order matter or does it not matter? Okay, go ahead and hit pause. Okay, so for the first scenario, 6 students are running for student government president, vice president, and treasurer. Student with the greatest number of votes becomes president, second is VP, third is treasurer. How many different possible outcomes are there for these 3 positions? Okay, so in this case, the order does matter. If I have 6 students running and I choose 3 different students, if I put 1 in president, 1 in vice president, and the third in treasurer, it's a different outcome if I mix them around, okay? So specific roles, again, it's gonna be a permutation. If we wanted to look at the setup on this, let's see, 6 students, permutation, we're choosing 3. Okay. Now what about this one? 6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility for expanding the park. How many different committees can be formed? So notice that the people in the committee don't have a specific role, right? Me, Sally, and Amanda could be on the committee. Well, that's the same committee as Amanda, Sally, and me. So this is going to be a combination. No specific roles. Right? So the order doesn't matter. So I would do 6 combination 3. Okay. Finally, Baskin-Robbins offers 31 flavors of ice cream. One of their items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? So if we think about if it makes a difference to make a bowl of vanilla, chocolate, and strawberry, is that any different from chocolate, vanilla, strawberry? Well, that's the exact same bowl, okay? The order that we put the scoops in doesn't matter. So this would be a combination. So we have 31 flavors, combination, we're choosing 3, okay? So our notation here, and we've already kind of talked about it, is that we've got the number of options taken R at a time. So R is how many we're choosing. Here's our formula, which we're not really going to be using. Those of you guys in Algebra 3, you might notice this is the same formula we saw in a previous section for the binomial coefficient. So basically it takes out the repeats. It's basically taking out the fact that these are the same combination, right? It's the same bowl of ice cream, okay? So our last couple problems. A 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from the 8 people on the board of supervisors? So we have 8 people, and we're choosing to make a combination of 3 people committees, 3 people on the committee. So typing this in, we do it the same way. Type 8 first, math, probability, this time NCR. We're choosing 3. So 56 committees. Okay. And finally, in poker, a person is dealt 5 cards from a standard 52 card deck. The order in which you are dealt the 5 cards does not matter. How many different 5-card poker hands are possible? So we've got 52 cards that we're choosing from. Order doesn't matter, so it's a combination, and we're picking 5 cards. Okay, so let's do 52, NCR, 5, and we have quite a lot of options here. 2,598,960 possible hands. And there we go. Okay, so homework is posted already, so you guys can do that. And this was our last video. So coming up the rest of this week, we have a quiz on Friday, and we have the final project or reflection, depending on what class you're in, due next week. Okay, I'll be sending information about the makeup assessment as well. So look out for that for those of you who need to make up one or more of the previous quizzes. All right, guys, have a great day.